Hello and welcome to Physics ka Doctor. My name is Dr. Ghanshyam Tejani and let's start class 11, chapter number 4, motion in a plane. And the similar content is covered in JEE NEET unit number 2 which is known as kinematics. So this is session number 9 of the kinematics and this is part of 1 that is projectile motion. So in this session we will be talking about not talking, we will be learning about projectile motion. What is projectile motion? And to be specific, majorly we will be covering horizontal projection. Horizontal you understand very well. Horizontal and vertical that we know. The next is time of flight, range, height of projection. Then of course the mathematical part is required. Everything is mathematical. But to be specific here, it is equation of trajectory of a projectile and what is our learning methodology to be by solving various example of NEET, JEE and JEE advanced. So let's start. See, in the previous sessions, let us just recall what we studied previously. And if you think that you need some background of the previous session, I think you should search Physics Doctor on YouTube and a particular topic. So you will get that. So what we studied? We studied previously what is position, position versus time, distance versus displacement, speed versus velocity, acceleration that are needed to describe the motion of an object along a straight line. So we studied one dimensional object, one dimensional motion. So displacement and distance, one topic we have on distance and displacement. Then speed and velocity, what are the difference in between speed and velocity? And the full session, it is more than 1 hour session with so many examples we have. Then motion with uniform acceleration and motion under gravity. So both are having one topic for each of them. Then we have instantaneous velocity. We already studied instantaneous velocity. We studied relative velocity in one dimension and the graph. We have 7 sessions of graphs: position time graph, velocity time graph, acceleration time graph. But it doesn't stop like that. It can also be velocity and position time graph, acceleration and positive time graph. These all things may be asked. So if you want to learn, I think you should search on YouTube Physics a Doctor and you will be having all of these topics. Also we studied vector. So in the chapter, in the current chapter, we also have a topic vector, and the vector, a math tool, it is fully covered in the previous session. So I think if you want to learn vector quantities, their characteristics, dot product, what is cross product, and various examples, you should search it. Physics adapter, vector, a math tool. You will get it. So in this case, we study scalar and vectors, difference between these two, how addition and subtraction can be done for a vectors, dot and cross products. So this all things we already covered. Now what? Now we are here in the chapter which is something talking about two-dimensional movement or two-dimensional motion. And the projectile definition is given like that: if a particle is freely projected in the air in the direction other than vertical, we observe that it moves in a curved path. Such objects are called particles. This definition is given. We can see examples are a football. When we kick a football, what happens? It has some kind of path, parabolic path. Yes or no? A cricket ball, a basketball. See, if you see almost all kinds of this majorly outdoor games, we see a motion. Say, for example, this is a basketball example is given. A person is throwing a ball for the basket from this position And the path, you can see there is a path, look like some curvature. Ball is moving in, and there is a basket, and there is a goal happens. Is it called goal? I don't know. So see, it is mentioned like that a particle is freely projected. That means it is thrown on air, right? So it is having two dimension. One is along x direction, and the movement is also having along y direction. So any object which is having two dimensional movement, x and the y direction, right? So that kind of movements or that kind of motion study we cover under projectile. And to be specific, that particle means here ball, here it is a ball, this is basketball, it is known as projectile. And we are going to study this. See, in the day-to-day life, we usually see this kind of movement, how this ball moves. See, projectile it is given for the two dimension, but this projectile it is true if we move the object vertically and if it is having one dimension, then also motion is like a projectile, but it is just a vertical movement going up. Object is going up and it is moving down. But in the textbook, the definition is given for the projectile, which is having two movement, which is object is moving along x-axis as well as along y-axis. There are two motions are seen, and we can see large number of example for this. For the design of a rocket or maybe aeroplane or in the game, football, basketball, cricket, what you name the game. Most of the games are having this kind of rules. And you see, players usually practice to get the best and who provide conclusion that you should hit the ball with this force or maximum, minimum, or at what angle it is giving the best range, best result. Yeah, we usually provide them this kind of solution. So projectile, we are going to study objects two dimensional movement. See, till the time we studied only one dimensional movement, but now this is a high time we will be studying two dimensional movement, and thereafter three dimensional movement. Hey, don't worry, you don't have three dimensional movement in your study, so there is nothing to worry more about that. So here the motion of the component has two. A motion of the component has a vertical component, means body is moving. See, if you see there is an increase of height, there is an increase of height, there is an increase of height if we compare this, and the body is also having horizontal components. So there are double movement is seen. Double movement, when we talk about projectile, it is having x directional movement as well as y directional movement. And if we go back in the history, so who derived this? We know that Galileo, we heard before that also, right? Galileo. So we heard from where the definition of acceleration was given by Galileo, Sir Galileo, we should say. Acceleration, it is given as it is having any body which having a free movement in the air, which is having a constant acceleration. That means its a change of velocity is directly proportional to its time, or ratio of change of velocity to the time. It is constant, and that definition was given by Galileo. And Galileo presented, or you can say first started his independence of horizontal and vertical component of projectile motion, and he presented his research study on the projectile body. So there are large number of conferences we usually have nowadays. Also, we usually have conferences. So in the 1632, he presented his research on this projectile in the conference called Dialogue on a Great World Systems. And thereafter, we have a detailed study of projectile. And because of that, we have planes, we have helicopters, we have excellent games, and thanks to Galileo and so many other scientists also. So let's move. Say, for example, here it is asked that two balls of different masses are thrown vertically upward with the same speed. They pass through the point of projection in their downward motion with the same speed. Neglect air resistance. So the question was asked in JEE 1983. So previously, maybe examination name may be different, but just I mentioned for you that it was asked in 1983. And it was about true and false. Two balls of a different masses. So let us have one ball is having bigger masses m1 are thrown vertically upwards. Maybe one day movement we can consider vertically upward with the velocity v, and another ball it is having smaller mass, let's go m1, which is also moved vertically in the upward direction, and we are not considering air resistance. We know that there is a resistance always present. So when a car, let us have an example of our favorite car, a car moves on a road, and if we do not, or you can see if we turn down this engine, what happens? After some time, car stops automatically. Because of what? Because of there is some resistance on road or by road. There is a friction, and because of that, car stops after some movement. Similar case is also true when we talk about object moves on air. So object is having air resistance. But this air resistance is very small, very small, and most of the cases it can be neglected. So we are not confusing here with a complex air resistance theory. So majorly we can neglect air resistance as the final result it is not having major its effect. So tell me, is this statement true or not? So what happened? Two balls of different masses are thrown vertically upward with the same speed. Velocity is the same. They passes through the point of projection in the downward movement with the same speed, right? So the ball reaches at the top position, velocity becomes zero, then it moves in the downward direction. Similar, this ball moves upward and in the downward direction, right? So what is mentioned here? It is asked that the projection in the downward motion with the same speed. So if it is having v, right? So in the downward direction also it should have a negative v. In the opposite direction, same speed but negative. Fine. So is it true or not? Yes, of course. See, if we see all the equation of motion, v is equal to u plus at. Where is mass? There is no mass component. See here, acceleration is because of gravity, and this is always minus g. There is no mass component. There is no mass component, right? If you see another equation, s is equal to ut plus 1 half at square, v square is equal to u square minus 2 as. Where is it is plus, fine. So see, there is no mass component. It is added. That means it is not dependent on mass. If there is a consideration of negligence of air, then only it is possible. You may argue that if I throw a ball from the 100th or we can say 10th floor building, and if I throw some light weight, maybe a leaf or whatever, so you argue that yeah, it is taking leaf, it is taking much larger time compared to ball, but it is because of only air resistance, because air is subjected to, you can say a leaf is subjected to huge resistance, that's why it is to be there. But if we run this experiment on 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 where on where on sky, not on sky, if it is not having any resistance, if we just have no resistance system, if we develop this system as a no resistance, then we can have this kind of solution. So it is true, because acceleration of gravity is independent of mass of the body. It depends only on gravitational acceleration. So all the bodies are having equal acceleration and there is no difference. So this is one. Second is a projectile fired from the ground follows a parabolic path. The speed of the projectile is minimum at the top of its path. So see, we are in the topic, we are just studying this topic, and we can see if object it is thrown. Right? So path will be projectile. Yes, a path is projectile. We will prove this path is projectile. Don't worry at all. And see, when we talk about object is moving in the upper direction, say for example, if object is thrown on the vertical also, so when it reaches to top position, of course, velocity becomes zero, and then it goes in downward direction, velocity neglected, it becomes negative. See, similar case is applicable when we throw the object in the horizontal direction and in the vertical direction, it is having a simultaneous movement. So horizontal, it is having some kind of at the middle position, horizontal movement it is there, but vertical movement become zero. It motion becomes zero. So yes, true. Also, from the conservation of energy at the highest point, potential energy is maximum. We know that therefore kinetic energy and hence speed should be minimum. That we know it. We will study also in the kinematics part also. Now we have some basic understanding of projectile. What is projectile? Any object which is thrown on air, say for example object, or say for example it is, let's go, ball hit by a cricketer for a six. So what happen? The objects moves, or you can say take projectile or path like that, and it has two component. One, it is having horizontal component, and another it is having vertical component. So let's analyze this part here. So here object, it is given some motion, initial motion at some direction. Let's call this direction theta or angle theta with x. Remember, here we are considering angle by default angle with horizontal plane, or you can say x plane, with horizontal plane or x plane, and it is u, it is considered as a initial velocity. Some of the books you can see there is a u0 or v0, it is used. Both are similar. You can use, majorly we will be using u as a initial velocity, and v as a final velocity or intermediate velocity, but other than initial velocity. So object, it is starting from point O, and it is given some velocity in the direction of u with angle theta with respect to x. So because of that we know this object is having two components. If it is thrown in this directions, we know that there are two components, one along x axis, and we know that if this angle is theta, so it become u. Nearer angle is always given cos theta, and it is having another component. It is having on the vertical direction, so it is having u sin theta. Angle which is away from this, so for that it is sin theta, and nearer angle we will be having cos theta. That we know very well. So this object, it moves like that along the x and y direction, and we will understand what is trajectory, what is range, what is height to be taken. We will understand, just wait. So here the projectile motion has a vertical component and horizontal component. So we taken these two components. One is horizontal component. Let's call horizontal component is equal to u x, and the vertical component, let's call this is u y. So throughout this chapter, we will be considering ux as a horizontal component and uy as a vertical component. So here if we consider, see, vertical component of motion is subjected to gravitational retardation, or you can say gravitational effect. So it is like that, if a ball, it is here, it is going in the upper direction, when it reaches to on the top most position, so we know that initial velocity may be u, but when it reaches to the top position, so velocity becomes zero. Velocity becomes zero. So in this case, it is also similar case. It is having minus g gravitational acceleration in the opposite direction. And because of the Norman, when this object start moving in the downward direction, so this gravitational acceleration, it is increasing its velocity in the negative direction. Because of that, objects moves in the downward direction, and here always u is equal to v. U is equal to v when we neglect air resistance. When we neglect air resistance, this become equal. And see, effect of air resistance is negligible on most of the component, and therefore for the basic study it is not required to consider everything. Otherwise, study will be very complex. So this is one. So here vertical component of motion is subjected to gravitational retardation. But see, while the horizontal component, it is not having any resistance. Horizontal component is not having any resistance, as air resistance is neglected, so it is not having any component. See, there is of course when object is moving in this direction, horizontal direction, when we see, so there is a retardation, but what kind of retardation? The object is moving in the direction, we call it Vx or Ux, and it is having its acceleration, or you can say gravity, in this direction, minus g. See, both are at 90-degree angle, therefore gravity is not directly affecting this horizontal movement, and because of that, horizontal movement of a body which is projectile is not changing, means velocity remain constant in the horizontal movement. So under horizontal component, velocity is constant, but when there is a vertical movement, velocity is first decreasing and then increasing in the negative direction. That we need to consider here also. So let us consider first horizontal and vertical component. So we know that ux is equal to u cos theta, that we already seen here. From this, uy is equal to u sin theta, that is also seen. Then when we talk about horizontal movement, the object movement horizontal, see, there is no acceleration in the x direction. When there is a movement, is free movement, so there is no acceleration. If there is some acceleration is given during this movement, or retardation is given, at that time we have to consider. But for the free moving body, there is no acceleration. But for a vertical movement, of course, for a vertical movement, we know that there is an acceleration, which is because of gravity, and which is to be considered minus g. Now we have equation of motion. We already studied this equation of motion. If you have any confusion about equation of motion, then we have sessions on this equation of motion, where we are talking about a one dimensional movement of an object. You may study this. So we already have this three equation of motion, where first one, it is v is equal to u plus at. This is second equation of motion, s is equal to ut plus 1 of at square, and third equation of motion, v square minus u square is equal to 2as. See, here also in the projectile, this all the equations are applicable. That means if you do not remember motion, or you can say equation for the projectile, then these three equations are also useful, or you can derive equations from that. But I do not recommend, as you don't have that much time during examination. So you derive equation first from these three, and then you solve the example. So I simply suggest that you should remember equations for projectile as well. So let us derive equation of motion which are useful. See first, see all of these equations, the first equation is equal to V is equal to U plus AT. So we can write Vx is equal to U plus AT. So VU is equal to initial velocity and V is equal to final velocity. But see for horizontal we know that there is no accelerating part, so A becomes 0. In the horizontal movement there is no A. So Vx, or you can say after some time velocity in the x direction is equal to Ux, and we know that Ux is equal to U cos theta. Ux is equal to U cos theta. That means its component along x axis. So I think this term should be very much understood by you. There should be no confusion. Then similar here for the V equation is similar. V is equal to U plus AT. V is equal to U plus AT. When we talk about direction Y, so it becomes UY, AY, and time required for that same motion. So see that Vy, that means it shows a vertical motion after t time, and uy it is showing the component of initial vertical moment. So uy is equal to u sin theta. So we can put here vy is equal to u sin theta in terms of uy here. And acceleration, we know that it is subjected to negative g, acceleration that become negative g, and therefore equation become like that for the vertical movement. Vy is equal to u sin theta minus gt. So one is x component, horizontal component, and this is a vertical component. So we have two components, one is x horizontal component and second is a vertical component. So see, we derived some of the equations from equation number 1. Let us derive equation from equation number 2, motion equation 2. S is equal to ut plus 1 of at square. So we can take as in the horizontal direction x, horizontal direction at any particular time, Sx is equal to, equation is equal to ut plus 1 of at square in the which direction, in the x direction. So we can have x near x. So we have x, ux, we have, do we have ux? Yes, ux is equal to u cos theta, and only t was already there. Then a acceleration, see in horizontal component there is no acceleration, so this term becomes 0. This term becomes 0. So we have in the x direction movement is equal to ut cos theta. We got this ut cos theta. Similar, when we talk about a vertical movement, so similar it is applicable here. It become sy for the vertical movement. Here it become uy, ay. So equation is equal to uy. We have uy is equal to u sin theta. It gives u sin theta plus c 1 half, and a become minus g because gravity it is subjected to negative part and t square. So we have here sy is equal to u. You can bring this t in this direction. Ut sin theta minus 1 half gt square. So this is used when there is a distance is asked. See, this is used for the distance. This is used when there is a velocity is asked. And the last one we have motion, third equation. It is for velocity. You can say that we already have one equation for velocity. Let's say why not another equation for velocity. See, this equation is when time is given, at that time this equation is useful, but when time is not given, say for example displacement is given, say for example at certain time object is travel at this position, so find velocity. So in this case last equation is useful. So we know that equation is given like v square minus u square is equal to 2as If we calculate in the x direction, so Vx at particular time, say for example at particular time Vx we want to find here, so it become Ux and 2 like that. So it becomes Vx square minus Ux. We have Ux is equal to Ux U cos theta square is equal to acceleration is 0. There is no acceleration. Body horizontally moving at constant velocity. So we know that V square is equal to U cos theta. So one thing we got V square, Vx square horizontal component U cos theta square. And what about y equation? Let's take again V square minus U square is equal to 2 as. So horizontal component we already did Vy minus Uy square is equal to 2 acceleration along the y direction, so it is negative g minus g and movement sy. So we have same equation sy, we already have sy is equal to u sin theta we can put. So see, we have here three different equations. We can name this equation as a 1, this is 2, this is 3, and from this three equation we can derive equations from for the projectile. But before we derive equations for the projectile, let's move on to understand some of the terminologies. So first is velocity of projection that we already studied. See, the velocity with which the projectile is projected at certain angle. So here we know that u, that is the initial velocity of projectile, which is known as velocity of projection, and it is at theta. We will consider this as angle as a theta, this angle as a theta. So first is velocity of projection, which is very much important. Second is angle of projection. So this angle made by direction of projection. So this is the direction of u with horizontal axis. So this is we call as a theta. Angle of projection we call a theta, and then a trajectory. So see, path traced by the projectile is named as a trajectory. You can see here the object is moving, maybe a ball, let us consider a ball. Starting from this position, it goes in this particular trajectory. We can take few points. So this a path traced by a ball, which is called a trajectory. Then what next? The next is horizontal range. Next is horizontal range. See, horizontal, that means what? Along the x direction, this is a movement of an object along the x direction. So horizontal distance through which projectile travel, right? So it starts from this position and it ends at this position. So that is known as range. That is known as horizontal range. Initial point to final point along x direction. You can see displacement of an object with respect to x. So it gives straight line, shortest distance from the first point to the last point. So that is horizontal range. And next is time of flight. Time of flight, that means if you know the time from starting position, ball is moving with this trajectory, and when it reaches to end point, so what time is taken? Maybe 10 second, maybe 100 second, 1 hour, 10, whatever it is time of flight. And lastly, the maximum height means maximum height. You can see here maximum height, it goes on the maximum y component when y become maximum. So this is to be considered as a maximum height. In this chapter, we will be studying motion of projectile. So we will be studying first horizontal projection, so ground to ground movement with the same level, with the similar level, ground to ground movement with the similar level, ground to ground with a different level, as well as from height, maybe from certain height to the ground. So object can move from ground to ground, or maybe ground to some other different ground with a different height, or a height from certain height object is thrown from certain height, right? We'll be taking this kind of example. So this session is majorly focusing on horizontal projection and ground to ground on the level ground, we can say. Then next is inclined projection on a level ground. So in the third part of the projectile, we'll be talking on inclined projection on the level ground. In this session, we will be focusing on ground to ground, or you can say level ground, horizontal projection. In the next session, we will be studying height to ground. So object is thrown from certain height to a ground. And then next is inclined projection on the level ground. Inclined projection with a point of projection and point of strike at a different level. And the fourth one is inclined projection on inclined plane. We will be talking about this all. So different, if object is thrown and it is reaching like that, or it is reaching on the horizontal plane, or maybe object is thrown from a building, how it behaves. This all will be studied here thoroughly. So don't worry at all. Let's start first with horizontal projection with ground to ground. So here we know that projectile, the object, it is starting from here, object is moving along this. So what is the definition of time of flight? So it is a time taken by a projectile when it starts from initial position and it reaches to the final position. So during this time, if you measure here, time is equal to 0, maybe here at time is equal to 10 second. So this is a time of projection, time of flight. Good. So from the last equation, we already have equation of motion, and we have equation s is equal to s is equal to ut plus 1 half at square. We have all of this equation. If we take equation along the y direction, if we take equation along the y direction, right? So here we can write sy means vertical movement is equal to uy. T will be same for that, and this become a become minus g, right? So see, when this object reaches, okay, starts from this position, it moves on the upwards direction, it reaches to top position, we call this as a height, this as a height. Again it moves a fly, and on the ground when it reaches to opposite side on the ground, so what is height of this, what is height of the final? So we know that height at here it is 0, and at initial position also height is equal to 0. Yes or no? Yes, of course. So we can use this equation sy, that means it is showing height. We know that uy, when we take vertical component, so it gives u sine theta, and object which is having vertical movement, when we talk about vertical movement, so it is subjected to minus g. So we can write sy is equal to ut sine theta minus 1 of gt square. We have already seen this previously also. And for the entire flight, we know that sy becomes 0 for the initial condition and the final condition. For both the cases, it becomes 0. So here initial and final points are the same. So ut sine theta is equal to minus 1 of gt square. Can we take t outside? Yes, of course. So it becomes 2 u sine theta minus 1 of gt square. We know that there are two possibilities. One is time is equal to 0. So at the time is equal to 0, object is here. But we need to have time is equal to some other value, some positive value. So we have t is equal to 2u sine theta by g. So this is equation is used for time of flight. So remember this equation. You have to remember this equation. First equation is used for time. T is equal to 2u sine theta by g. You have to remember this equation. Next is horizontal range. So you can see here R, it is a distance, horizontal distance traveled by a projectile from a 0 point to the finally it strike on the similar level, on the same level. So we have again the equations. We have equations. So let's have equations of the horizontal part. We have equations for the horizontal part. S is equal to ut plus 1 half at square. We know that horizontal component is not subjected to acceleration, therefore this component becomes 0. This becomes 0. So S is equal to ut when we talk about horizontal component, S x ux, so is equal to S ux t. And what is ux? It is ux is equal to u cos theta. Ux is equal to u cos theta. So similar here, Sx, here it is there. Ux is equal to u cos theta. You can move this t on the front side, it becomes u cos theta t. We can move t here, so ut cos theta. It become ut cos theta. Sx is the distance travel. Sx is distance travel from the first position to the last position, and that is known as range. That is known as range. So we can put here Sx is equal to range. Sx is equal to range ut cos theta, and the see value of t we already derived the time required for this movement t. It is here, put the t is equal to 2u sin theta by g. So put here, so become u 2u sin theta cos theta. So we know that 2 sin theta cos theta, 2 sin theta dot multiply by cos theta is equal to sin 2 theta. Put the here value, so it become r is equal to u square sin 2 theta by g. So this is a range. This is a range when the object is projectile on the similar level of the ground. So it give range. This is the range. So we talk about range, we talk about height. Wow, great. The next is maximum height. When we talk about range and time, we didn't talk about maximum height. So see, during this flight, if you see here for a particular point, say for example A point, so it is having some height. It is having some height. Let's call it h1, or you can say y. It reaches to at this position. You can see here it gives h become maximum. H become maximum. So this maximum height happens where vertical component Vy becomes 0. Vertical component of velocity when it becomes 0, at that time height is maximum. See, initially what happened? U, it is having two component. It is having two component. One is U sin theta, and horizontal component is U cos theta. See, horizontal component is constant. It is not changing. It is not changing. But vertical component, it is reducing. Here it becomes 0. Here it becomes 0, and where we can find maximum height. So at maximum distance, at maximum height, velocity of vertical movement is 0, not horizontal. Vertical movement is only 0. So we have equation v square minus u square is equal to 2as. For the vertical movement, we know that Vy, we have Vy, then for the u, we have u sin theta, but here v becomes 0, v becomes 0. U is equal to, we can put u is equal to u sin theta square is equal to 2, become a become minus j, s become sy. So s become height, sy become height. That is the maximum height. Put this value here. So we can have h is equal to u square sin square theta divided by 2g. So these three equations you need to remember. This is equation number 1. T is equal to 2u sin theta by g. Equation number 2, range. u square sine 2 theta by g, and this is height, u square sine square theta by 2g. You can solve all of this example by using equation of motion 1, 2, 3, but the process, you can say, time it is consumed for that. So I simply suggest you should remember these three equations. Otherwise, process I already explained. The concepts must be very much clear for you. So let's move here. See here, it is mentioned the time required to reach maximum height. So Vy is equal to u sin theta minus gt. Vy is equal to 0 equations. You may remember or you may derive directly from the previous three equations. Say for example, first, time required to reach maximum height. See, we have a time of flight. That means object starts from the beginning 0 and it reaches to final position. But say for example, sometime if it is asked that to derive time to reach at maximum position. So that means half of the journey. Half of the journey. See, you can simply say that this should be t by 2, flight of time divided by 2, because when we consider resistance, air as a negligence at that time, you need not to worry about that. But we can also derive at maximum height. At maximum height, velocity is 0. We already have this equation Vy is equal to u sin theta minus gt. That we know that V is equal to u plus at. For vertical height, it becomes g, and that we know. So from that we can put when we reach at maximum point, vertical vertical velocity becomes 0. At momentary instantaneous point, it becomes 0. So t is equal to u sin theta by 2. The similar equation that we have, t is equal to 2u sin theta by g for the total flight of time. Here, this is the equation for half flight of time. You can derive or simply you can take half for the flight. Then maximum range. So see, we already have equation of maximum range if it object reaches here. But see at what angle if you throw a ball, right? For particular velocity, we can have a maximum distance travel. Say for example, if you want to hit a six in this Australian cricket ground, those are big grounds, 80 or 90-meter distances they are having, and if you want to get this, so what should be this angle? Because your capacity to give velocity is limited. A person's, you always go for maximum, but at what angle it should be? So it gives maximum range. See, we have equation for range is equal to u square sine 2 theta, and if we have sine 2 theta is equal to 0, no, is equal to 1. So at that time r become maximum. At that time r become maximum. U square by g, it gives maximum. When sine theta become 1, so we know that 2 theta is become 90 degree. That means theta is equal to 45 degree. So if you hit a ball at 45 degree, it travels maximum. The range become maximum at theta is equal to 45. R is maximum is equal to u square by g. U square by g. It may be possible that see maximum height. Not talking about this height, but you can say at a particular angle. At what angle object is to be thrown, so we can reach maximum height. So we have equation for height. H is equal to u square sine square theta by 2g, which give maximum height. If you wanted to have this as a maximum, sine theta should be 1. And when sine theta is 1, theta is 90 degree. That means if you throw a ball exact vertical, at that time it gives maximum height, so it becomes u square by 2g. It gives u square by 2g. So you can have, see, this kind of examples will be there in the NEET and JEE examination. You will be solving this kind of examination. Therefore, this is very short examples are required, and therefore we have taken this. So let's start with some of the example. And example number one is mentioned here. What is mentioned? A body is projected with of velocity 30 meter per second. So this is given, velocity is given, or you can say it is initial velocity. So we will write as well always u 30 meter per second at an angle theta. So it is not theta. See, angle of 30 with vertical. You have to remember this part. Our angle is not vertical. Our angle is horizontal. So theta is 90 minus 30 is equal to 60 degree. See, this kind of certain changes will be there, and if you do not understand, or you forget to convert this, your answer will be wrong, and the wrong answer will be available in the option. Believe me. Find the maximum height. Oh, time of flight and horizontal range. We have equations for all of this. So u is equal to 30 meter per second, theta is equal to 90 minus 30 degree is equal to 60. We need to find height, we need to find time required for that, and we need to have range. Do we have equation? Yes, we have equations. T is equal to 2u sine theta by g, r is equal to u square sine 2 theta by g, h is equal to u square sine square theta by 2g. Do we need to remember all the equations? It is better to remember, of course, it is better to remember equations. It will help you a lot. You can solve examples without these equations also. You may derive equation at a time of requirement, but I don't suggest, because that much time is not available in the examination. That's all. You just need to put the values here, nothing else. So we h is equal to u square sine square theta by 2g, u is equal to 30 sine square 60 divided by g 9.8, or you may take 10. If it is not given, default you should take 10. So h is equal to 34.44 millimeter height. It is to be taken maximum height for this projectile. H is 34.44 meter. Then we have t equation for t. We have equation for time of flight. So t is equal to 2u sine theta by g. 2u sine theta by g. So put this value here. U is equal to 30. Theta is 60 degree divided by 9.8. So t is equal to 5.3 seconds. And what about last? We have range u square sine 2 theta by g. Put the values here. U is equal to 30 sine. It become 120, and you can get answer is equal to 79.53. You also have to remember angles for sine 30, sine 60, whatever, sine 15, sine 45. These all angles are commonly used, and you have to remember this. Then what next? Oh, example number 2, and it was asked in All India Pre-Medical Test 2011. So a missile is fired. Oh, missile, a missile. Let's do a missile. A missile is fired. Wow. For a maximum range, so it should reach at some other country. Wow, at maximum range. R max. With an initial velocity. So U is given 20 meter per second. If G is 10 meter per second square, the range of the missile is, oh, what should be the range of the missile? U is equal to 20 meter per second, theta is 45. You know that theta should be 45 to get maximum range. This should be 45. Initial angle should be 45 to get maximum range. We have R max is equal to U square by G. We have this equation. Put this value U 20, G is 10, and our solution is 40 meters. So it will reach 40 meter. The missile will cover 40 meter. Very easy? Yeah, of course, it is easy. Let's move. Sometimes you may have easy question also during examination. So it's not necessarily always that will be a difficult. Most of the questions are easy. And what is difficulty level and easy level? See, difficulty, that means if you don't understand, that means it is a difficult question if you are not prepared for that. If it is a surprise in the examination, then it is difficult question. If you know the answer, you know the method, then it is not surprise for you, it is not difficult at all. So difficulty level varies from person to person. It depends on how you are ready for the next camp. So example number 3, it is from NCRT book, and believe me that you always should solve all the example from your book NCERT. See, all the concepts are coming from NCRT books. You must read and as well as solve all the examples, everything, all the theories from the NCERT book. So example is given: a cricket ball is thrown at a speed is given u is equal to 28 meter per second in the direction 30-degree above horizontal. That means it is given angle with horizontal, so it is theta. Calculate the maximum height with the time taken by the ball to return to the same level. That means a ball starting from this position, it returning to the opposite position. So yeah, we need a time for this flight and the distance from the thrower, the point where returns to the same. Right. So we need range. So what we need here, u is equal to 28 meter per second, theta is given 30-degree, h is given not, t is given no, r is given no. So what next? Yeah, we have equations for all of this. We should solve directly from that. T is equal to u sine theta by g, r is equal to u square sine 2 theta by g, h is equal to u square sine square theta by 2g. You have to repeat these equations again and again, then only you will be able to remember. Otherwise, it won't work. Put all of these: h is equal to u square sine square theta by 2g. Put value of u and theta. Sine 30 is equal to 1 half. You can put this value here. So you can have h is equal to 10 meter. H is equal to 10 meter. Maximum ball will go at a height 10 meter. Good. Then next we need to have a time of flight when it reaches to opposite the similar level. Similar level. So put this value here and it become 2.9 second. In the 2.9 second, ball passes from start from this position and reaches to another position with the same level, and r is equal to u square sine 2 theta by g. Range if you want to find, so we have equation for that: u square sine 2 theta by g. So we can get sine 60 is equal to root 3 by 2. You can keep root 3 by 2 as it is. Sometime in the examination of JEE NEET, such conversion may not required many a time. So range is equal to 69 meter. The distance from first when it start to the end, so that becomes 69 meter, almost 6 in the Indian ground. Let's move to the another example. Drawings are coming fast. So example number 4, a football. Those who are football lover, this is example for them. A football is kicked from a ground horizontal. So football it is here, from that it is kicked at some velocity u and at a theta angle. So there are two components are given. Initial velocities are 6 meter per second and 8 meter per second. So here horizontal component, we know that horizontal component u x is given and vertical component is given u y. 6 meter per second and 8 meter per seconds are given. So horizontal is 6 and vertical is given 8 meter per second. Find the range, maximum height, and time of flight. See here, u is not directly given, and angle is also not given directly. So what can we do? It is now it is very simple. It is not big deal. So we have that u x is equal to u. Near angle is known as cos theta, so we know cos theta, and uy vertical is u sin theta. So u cos theta is equal to 6 meter per second and u sin theta is equal to 8 meter per second, and we need to find this all. That's all. We have some equations are like that: 2u sin theta by g o, then u square sin theta by g o, and h is equal to u square sin square theta by g. But we don't have equations in this form. So what can we do? Let's start. R is equal to, first let's find range is R. So range. So u is not given, sir, here. So what can we do? What is sine 2 theta? Sir is equal to 2. We can write sine theta cos theta. Oh, mathematics is required here. I think yes. So 2 sine theta cos theta. Can we separate this like 2 u sine theta u cos theta? Do we have value for u sine theta u cos theta? Of course, we have value for u sine theta is 8 meter per second and u cos theta is 6 meter per second. Put this value here, j is 10. So here we have r 286 divided by 10, it is 9.6 meter range. So question can be in this manner also. Then what next? Next is h is equal to u square sine square theta 2g. Can we write this equation in the like that u square sine theta, not u square, u sine theta square. Do we have value for u sine theta? Yes, it is 8. Yes, it is 8. So let's put here 8 square divided by 2, 10 is equal to 3.2 meter. Oh, yes, 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 sir. It is now, it looks very easy. Then what we need? T. We need T. We need T. Oh, we need T. Good. So T is equal to 2u sine theta. U sine theta, we have value 8 meter per second. Put the value here. So time of flight is 1.6 second. These examples are very simple. Oh, wow. And last is angle. We have divide. You can divide this u sine theta by u cos theta. U sine theta by u cos theta. So sine theta by cos theta is equal to 8 by 6 is equal to, can we write 4 by 3, and 4 by 3 we know that this angle is very much required, right? So you remember 37 and 53 angle. See 37 angle in the opposite side it is 3, nearer side is 4, and this hypotenuse is 5. Remember this 3 4 5 3 4 5 3 4 5, and one angle you just remember one angle, opposite angle is okay. So here it become tan theta is equal to 4 by 3. If we take this tan theta, right, so is equal to opposite angle. No, it is equal to what? It should be what? What should be what? You give me answer and tell me whether it is a 57 or 37. It is not 57 or 37, it is 53. So we know that tan theta is equal to opposite side divided by a nearer side. So I suggest that you remember this also with this 30-degree angle, 45-degree angle, 90-degree angle. With that, you remember 37 and 57 will be automatic, because there are many questions they usually ask for this particular angle 37 and 53. Oh, let's move to the next example. Example number 5 says that find out the relation between UA, UB, and UC, where UA, UB, and UC are the initial velocities. That means it is velocity, it is having UA, this is having velocity UB, and third component is having velocity UC of the particle UAB, particles ABC respectively, and the drawing is also given. Let us derive some of the conclusions from the drawing. So we can say first height of each of the component through one, it is having equal. So that means height HA is equal to HB is equal to HC. HA is equal to HB. And if again we can see here there is a theta A, we can see here theta B and theta C. What we can say here, theta A is the biggest one, theta B is mid, and theta C is the smallest one. So we know that these equations are only there. We have to remember this all the equation, but the given is that HA is equal to HB is equal to HC. All heights are equal. Second is given theta A is greater than theta B is greater than theta C. So that is given. That is given. Another is given RA is less than RB is less than RC. RA is less than RB is less than RC. So these three things are given. These three things are given. Let's put here. Let's take R is equal to U square sine 2 theta by G. So we are putting here U A square sine 2 theta A divided by G. You can put here U square B sine theta sine 2 theta B by G less than U C square sine 2 theta by. So we can cancel this simply. G can be cancelled out. G can be simply cancelled. Then it become U square sine 2 theta A less than UB square sine 2 theta B less than UC square sine 2 theta C. See, similar equation you can also derive from this also, and you may cancel out this sine theta sine, and the angle you can also derive. You can also derive like that UA square sine theta A is equal to UB square sine theta B, and you can take a relation from that also. You can take relation from that also. So here we can move this sine 2 theta A on the opposite side. So what it become? It become UB square sine 2 theta B divided by sine 2 theta A. Now let us just consider here sine 2 theta B divided by sine 2 theta A. See, let us just consider here theta. If theta A is greater than, like, I can put 2 theta A is also greater than 2 theta B. Greater than. So here, if we take 2 theta B, which is a smaller than theta A, let's take sine 30, and the theta A is a bigger value, so let's take sine 90 for example. So what is sine 30? What is sine 30? What is sine 30? It is 1 by 2, and sine 90 is 1, so it is 1 by 2. It is 1 by 2. See, if you take any of the case, this value is always going to become less than 1, because sine varies from 0 to 1, right? And sine 2b is always having a smaller value compared to sine theta A, because sine theta B is smaller than sine theta A. So this is always going to have a smaller value. So this component is always having a smaller value than 1. So multiplication of smaller value with this any original value, it further reduces its value. See, even though the multiplication with the smaller value, it is giving a bigger value of UB. So ultimately it is multiplying with some lesser value, say for example zero point 0.5 or zero point 0.3 or whatever. That means ultimately this UB is even bigger than this. That's why ultimately you can write UA is less than UB is less than UC. Square, you can remove square. So UA is less than UB is less than UC. You can put here also H is equal to H1. So you can put UA square sine square theta is equal to UB square sine square theta A theta B. So you can take here UA square divided by UB square is equal to sine theta B divided by sine theta. You can put these values here also here, and you can derive also. You just derive this solution and comment me your answer below. Now next is example number 6 is from All India Pre-Medical Test 2012. The horizontal range and the maximum height of a projectiles are equal. See, here it is given like that. Object, it is projectile. It is, so we know that from first point to last point, this is known as a range, and this is height. If both are equal, the angle of projection of the projectile is, four options are given. Theta is equal to tan inverse 4, theta is tan inverse 1 by 4, theta is 45 degree, theta is tan inverse 2. Wow. For the theta 45, we know that branch is maximum, but we don't know that r is equal to h. No, such relation was never there, so this option is not applicable. Fine, so we have all the equations. T is equal to u do this. We need here equation of range and height. So we have here r is equal to u square sine 2 theta by g, and h is equal to u square sine square theta by 2g. Can we put both are equal? Yes, it is given. R is equal to h is given, so we can put h is equal to r and r is equal to h. So what here next? What next? Oh, can we cancel out this because it is given that initial speed, because it is the speed of the similar object. Can we cancel out 1g? Oh, of course. So it becomes sine 2 theta. We can write sine theta cos theta. One sine can be cancelled out. So it become, yeah, it can move to opposite side 4 cos theta. One sine is cancelled out. Out of that, one sine cancelled out, one sine remain. So it is tan theta is equal to 4, because tan theta is equal to sine theta by cos theta. You can put cos in this opposite side. So tan theta, theta is equal to inverse 4. It is there. Oh, answer number 1 is the correct answer. Example number 7. Two projectiles are projected with the same initial velocities at angle 30 degree and 60 degree. Oh, two objects are projected at the same angle. One is projected at 30 degree. One is projected at 30 degree. So this angle is 30 degree, and another angle which is projected at 60 degree. What with the horizontal? Then option are their heights will be equal, their range will be equal, their time of flight will be equal, or their ranges will be different. So four options are given. Let's check. See, these are the equation, right? So these are the equations. Can we put h1, h is equal to u square sine square theta by 2g. So h1 initial velocity is equal. So here become u square sine square theta. Theta is only different 2g theta 1, right? We can take ratio. So you can divide this u1 sine theta 2 square divided by 2g, g 2g 2g cancel, u cancel, because it are having initial velocities are same. So here ultimately we have sine square 30 by sine 60. Sine 30 is 1 of sine 60 is 3 by 2. The 2 cancel, so it become 1 by 3 root 3 square 3. So see, this kind of questions you may see for the first, right? So their heights will be equal. So equation can have this component, their ranges will be equal. So we have range, you can take a ratio of the range r1 r2. Again u and g will be similar, so it will be cancel out. So become sine 2 theta by sine 2 theta 1 by sine theta 2. So 30 and 60, sine 60 by sine 120 root 3 by 2 root 3 by 2. Sine 60 and sine 120 both are having equal answer, and that become 1. That means what? That means what? See here, we got very important conclusion. When the object it is thrown at 30 degree or maybe 60 degree, at 60 degree, both are having equal range. Range is equal for both. Range is equal for both. See, whenever you find angle theta 1 plus theta 2 of the same object projected, if it is 90 degree, then always range is always equal. Always remember, for both the cases, range is always equal. Then time. So we have all equation for time. 2u will be cancelled, g will be cancelled. So sine 30 by sine 60, t1 by t2 is equal to 1 by root 3. T1 by t2 is equal to 1 by root 3. And the last option, the horizontal range will be equal to 30 degree plus 60 degree is equal to 90 degree. Therefore, range will be equal, not different. This answer is incorrect. Range will be equal, not different. We have one more question. Example number 8. A body is projected at an angle such that its horizontal range is 3 times the maximum height. Horizontal range is 3 times the maximum height. So here it is given like that. Object is moving like that. Here object is having height and it is having some range. And relation is given R, range is equal to 3 times H. Oh wow. We have equation, we put the equation. R is equal to 3H is given. Let's put here R is equal to U square sine 2 theta by G. 3 is equal to 3 U square sine square theta by 2G, because it is for the similar. U square you can cancel. G you may cancel out. What is sine 2 theta? 2 sine theta cos theta. We can remove one sine here, that becomes sine theta, and then 4 cos theta is equal to 3 sine theta. So we can write here tan theta is equal to 4 by 3. Wow. So tan inverse is equal to 4 by 3. See, such kind of questions you may have in the coming examination. Be ready for that. Very simple. It looks simple, but it may not be when it actually comes. And these three equations you have to remember. Example number 9. A body is projected at two different angles such that its horizontal range is equal. Find a relation between H1, H2 and R. So see here, a body is projected. Say for example here, the body is projected at one angle. Say for example theta 1, and the same body it is projected at some different angle. Say for example theta 2. Fine. So it is a body which having this may have a range R2, and the first body let's have the similar color and it is having a range R1, and such that horizontal ranges are equal. Oh, it is equal. Let's make this range equal. So horizontal ranges are equal. R1 is equal to R2. Wow. R1 is equal to R2. And H heights are different. Heights are different. Heights. We have different heights. So it is having H1. First one is having H1. Second one is having H2 height. Wow. So we have equation T is equal to 2U sine theta by G. R is equal to U square sine 2 theta by G. H is equal to U square sine square theta by 2G. You have to remember this equation. You have to repeat this equation many a time. You will remember. So first we have H1, H2 and R are equal. So we can put here H1 for the first ball, first flight at angle theta 1. So H1 is equal to U square sine square theta. Then we can put here 2gh1 is equal to u sine theta. You can put theta 1 also, that is also fine. For the h2, u sine square theta 90 minus theta. See, whenever we already know that, we already know. See, when both are having r1 is equal to r2. So here, always theta 1 plus theta 2, that must be is equal to 90 degrees. So theta 2 is equal to 90 minus theta 1. So we can take 90 minus theta. That we have to consider. So sine square 90 minus theta means sine 90 minus theta is equal to cos theta. So it's become h to become u cos square theta by 2g. You can take u cos theta is equal to under root 2g h2. Now it's time for height. Both are having equal height. Both are having equal height. Both are having equal height. Is it true? Is it true? No, both are not having equal height. Both are having equal range. So we can say r is equal to u square sine 2 theta by g. Sine 2 theta is equal to 2 sine theta. Here it is on the top side. You can see u square sine theta cos theta. We can rewrite it 2u sine theta cos theta. We have values for this. Let's call it is 1 and let's call this is 2. Put here in this equation. So become 2 under root 2 gh1 under root 2 gh2r. It become R is equal to 4 H1 H2. R is equal to 4 root H1 H2. This is the solution for this question. Now let's derive equation of trajectory of a projectile. See, drawing is given. You can see here there is a object is thrown at u velocity and having two component u cos theta, which is x direction component, u sin theta, which is a y direction component, right? And at a point P, what should be equation of trajectory or equation of motion? So we are interested in this equation. So here we already derived s is equal to ut cos theta because a general equation is s is equal to ut plus 1 of gt square. So when we are required to find along x direction, so it becomes ux time is equal for both the cases, and here it is not g but it is a, so it is a. See, along the x direction there is no acceleration component, it is not applicable. That means a is equal to 0. That means first term is not required, so become uxt, and here this is ux. So therefore as x distance travel along the x axis after certain time t, so it become u. This is u cos theta t. You can move t to become u cos theta. You can rewrite. So this is as x, and similar it is for the y. Let's remove some of this part. For the similar for the y, you can write y. Sy, that means y component uy. Uy is become u sin theta t minus, or you can say plus 1 half, this become minus g, this become t square. So you can put here sy component by sy is equal to ut sin theta minus 1 half gt square. We have this. So we have, see, y component sy is equal to y and sx is equal to x. We can put x here, x is equal to ut cos theta. So from that we can find t is equal to x divided by u cos theta, and similar y is equal to ut sin theta minus 1 of gt square. We just rewrite this equation, nothing else. Put this sy is equal to y and sx is equal to x. Wow, great. Then what next? Put the value of t. Yeah, so we have already have t. Put the value of t here. So u x u cos theta sin theta minus 1 of g x in downside x cos theta, because this was t, so we are putting values here t square. Can we have this u cancel? Yes, why not? Why not? Why not? We can put this here. We can put this here. We can cancel this out, and so it become x sin theta by cos theta become tan theta. Here g x square divided by 2 is inside, 2 use cos theta square. See, here we need to have one important conclusion. It is already there. If y is proportional to x square, thus the projectile is parabola. See, we know that if there is a relation y is proportional to x, so it is a linear movement. But if this is a square, so we have here one square, we have one square here, x square with some constant, right? So y is proportional to x square, therefore our object is having some projectile in the curvature, and when there is a y is proportional to x square, so it is a presenting a parabolic path, and therefore a body which is freely projected, it is always having a parabolic path, because it a relation is given here. So you can have y is equal to x t tan theta minus g x square divided by 2 u square cos theta. You please remember this equation. This is also very useful. Yeah, you have to remember so many equations in the physics. Then next is if you take tan theta outside, so tan theta is equal to 1 minus, you just multiply with tan theta, the second one in the division part. So here 2u square cos square theta tan theta, and we know that tan theta is equal to sin theta. Tan theta is equal to sin theta divided by cos theta. One cos will be cancelled, so it becomes 2 sin theta cos theta. So ultimately, can we have this big component u square sin 2 theta divided by g is range. So equation can be rewrite y is equal to x tan theta 1 minus x by r. So another equation you have to remember. So you have to remember both of these equations. Example number 10. Oh, find the least initial velocity. Talking about initial velocity with which a projectile is to be projected so that it clears a wall. See here some object it is thrown at some initial velocity u, so such that it should pass this wall which is 4-meter height located at distance 5 meter from the origin. It is located at 5 meter and strikes the ground at a distance 4 meter. So this all things are given. You need to convert this into drawing. If it is not given in the examination, drawing will not be there, but here it is given but it may not be. The point of projection is at the same level as the foot of the wall. See, equations are here taken. We have taken the equations. This already we proved. So please not this equation, and you have to remember this both of the equations. So we have all of these equations, right? And here we need a range because here 5 plus 4, so it become 9 meter. That is given also some height. So we can not take h, but we can take here this as a y, and from this equation. So at particular position point P, here it has to be crossed. So this equation it has to satisfy. This equation it has to satisfy, then it works. So we can find r is equal to range. Total range is 5 plus 4 9. Initial speed we are moving this object at u at angle theta, or you can say here we generally take theta, so we will be taking theta. U square sine 2 theta by g is 10. We can put here. So ultimately, u square sine 2 theta is equal to 90. We have one equation. Now what next? See, we have equations for this. Y is equal to x tan theta minus g x square divided by 2 u square cos square theta equal to x tan theta 1 minus x by r. It is better to have this equation. So can we have x? Yes, x, that means its present horizontal distance at a particular component is reaching at this position. So x is equal to 5, and at a particular position y is equal to 4 meter. Y is equal to 4 meter. So we can put here y is equal to x tan theta 1 minus x by r. X is equal to x is 5. Total range is 9 and x is 5. We don't know theta. So we can put 5 tan theta 1 minus 5 by 9. So it becomes 5 4 by 9. We can cancel this 4, and so tan theta is equal to 9 by 5. So if you want to find sin theta, you just what you do, tan theta is equal to sin theta divided by cos theta. So if you wanted to find sin theta, what you do, just take sin theta is equal to, just take this value 9 divided by under root 9 square plus 5 square. So you will directly get this angle. So sin theta is equal to 9 by 106, and similarly cos theta is equal to, similar here 5, this denominator divided by 9 square plus 5 square. So 106, you will have 106. So here we have u square sine 2 theta is equal to 90 degree. We have this equation. So we can get u square is equal to 2 sine theta cos theta. We have value of sine theta and cos theta. Put this value here. And so u square is equal to 2, 9 divided by 106, 106. So u is equal to 10.29 meter per second. If we have initial velocity u is equal to 10.29 meter per second, we can reach this wall if it is thrown at particular angle theta. If theta is asked, what we can do? We have equation here. We have equation. We can have tan theta. It is already there. Tan theta is equal to 9 by 5. So we can have theta is equal to 10 inverse 9 by 5. Right? Comment be your answer. Final angle. We have one more example. Example number 11. It is from JEE 2013 main. Wow. A projectile is given an initial velocity I plus 2j. Vector, you didn't teach us vector, so we have a separate session on all the vectors, not only single, we have several sessions on vectors. So I think you should search physics a doctor and the component with vector. You will get all of your questions over there. But we will repeat here also some component which is required. So what is mentioned here, a projectile is given an initial velocity of I plus 2j meter per second, where I along ground and j is along vertical. We know that g is equal to 10 meter per second. Then equation of trajectory is JEE 2013 main. This examination question was asked. So object is moving like that, right? And initial velocity is given. Initial velocity is given. So I component and j components are given. So it is I component, one I, and the j component is given to j. Wow. Oh, equation of, we have equation of trajectory, right? So many equations are given. Y is equal to x minus 5x square, y is equal to 2x minus 5x square, 4y is equal to 2x minus 5x square, and 4y is equal to 2x minus 25x square. So we have equation, we have to remember this equation, right? Y is equal to x tan theta gx square 2u square cos square theta. Can we take x? Can we take this relation for that? For the relation for that. See, we can convert, we can put here cos square theta also. We can convert this into cos, so it becomes x square theta. And sec square theta is equal to 1 plus tan square theta. You can rewrite this equation in this form also, or you may continue with the previous equation, whatever you wish. So, see, given it is u is equal to I plus 2j, this is a given data. I is given, j is given, both are given a unit vector. And if you wanted to have initial velocity, so we know that mod u is equal to i's component, so 1 square plus 4 square is equal to root 5. Now we got initial velocity. Now we got initial velocity. It is there. So u is equal to root 5, and in this equation we need u square, so it becomes 5. Then we need tan theta. We need tan theta. We need tan theta. So see, we have, this is our projectile. This is our projectile, and if this object it is projected at some angle theta, having u velocity, right? So if we wanted to have angle, so tan theta is equal to a vertical movement uy divided by horizontal movement ux. So tan theta is equal to uy by ux is equal to 2 by 1, right? You can convert this into cos theta 2 by root 5, like that. Cos theta you can take, you can convert this in this form also. It is not 2 by theta, but it should be 1 by root 5. Cos theta, it should be 1 by root 5. You can convert this in this form also, or you may use original equation, you may put this here. But it is better that not to use original equation, go with this tan theta is equal to 2 by 1. So put this equation number, all the values in the equation number 1. So y is equal to x, keep x as it is, tan theta is equal to 2, tan theta is equal to 2, the G is 10, x square is equal to x square, 1 plus 10 square is equal to 2 multiplied by 2, 4, and u is root 5, so 2 multiplied by 5. Simplify this equation, y is equal to 2x minus 5x, y is equal to 2x minus 5x square. This is example number 12 and it is coming from directly from JEE 2019 mains exam. What is asked? The trajectory of a projectile near the surface of the earth is given. So equation is given. See, as I mentioned earlier, all the time, you need not to remember all the equations. Also, you can derive from this equation also. So what is the trajectory of a projectile near the surface of earth is given. Y is equal to 2x minus 9x square. If it were launched at an angle theta 0 with velocity v0, then take g is equal to 10 meter per second, and there are options are given. Theta 0 is equal to sine inverse 1 by root 5 and velocity is equal to 5 by 3, and options are given. Now what next? So here equation is directly given. Y is equal to 2x minus 9x square. The trajectory of projectile it is given, so we need here theta and the speed. So we have equation of projectile motion. Y is equal to x tan theta minus gx square 2u square cos theta. Can we compare? This is x tan theta. Can we take comparison with this? So can I write tan theta is 2, and here similarly this is the entire portion. Can I write 2u square cos square theta is equal to 9? Of course we can. So let's write. So tan theta 0, as it is mentioned, it is theta 0 now is equal to 2. So ultimately, if you really wants to have cos theta, so we know that sine theta is equal to, you can say 2 divided by 2 square plus 1 square in the root, and the cos theta is equal to 1 divided by 2 square plus 1 is equal to, yeah, 1 by root 5. Wow. So we got tan theta 1 by root 5. So cos inverse 1 by root 5. Cos inverse 1 by root 5. So this is incorrect. This is incorrect. And this is also incorrect. We got answers number 6. Further, you may continue if you wanted to have velocity. So G, it is there like that. We have value of cos theta, you can put here. And also initial velocity u0, it is there. You can put u0 and you can find u0 is equal to, we need to find u0. U0 is not given here. Don't worry. So u0 is equal to 5 by 3. It is already there. So you already got answer 5 by 3 at half a way. See, the question may look difficult, very difficult, but you will have this kind of answer in halfway. In half movement, you will get the same answer. Wow. We have one more question. A ball is thrown from ground level so as to just clear a wall. Oh, we had solved this kind of example previously also. Yes, we had. So it is given. So we can take this is a point, and in the equation of y, this is y, and this become x. At a particular p x comma x, x comma y, x is 4, y is 4. At a distance 4, and we know this equation y is equal to x tan theta minus gx square divided by 2 u square cos square theta is equal to x tan theta in bracket 1 minus x by r. Right. And it is mentioned that, and a ball falls at a distance 14 meter from the wall. So it starts from here, it crosses the wall of 4 meter, which is away from 4 meter, away 4 meter, and then it crosses 40 meter. It travels 40 meter. So can I get range? Yes, range is equal to 4 plus 14 is equal to 18 meter. Good. So find magnitude and direction of velocity. We have all of this equation. All of this equation. Can use only equation of range because range is known. R is equal to 18 meter. Put the R is equal to 18 meter. G is 10. We don't know any other value. So U square is equal to 2 sine 2 theta. 180. Give the equation name 1. Oh, then what next? Yeah, we have equation of this big. Either you use the first portion or second portion. Which one is look easier? I think second looks very easy because it just required x value. We have x value 4. We have total range. Yes, 18. Tan theta. Tan theta you can derive from other part also. So y is equal to x tan theta 1 minus xr. X is 4. Y is 4. Tan theta 1 minus 4 by 18. So it is 4 tan theta. You can cancel this 4. Why this 4 is required? You just cancel out. So tan theta, you just divide this. So it becomes 9. 7 by 9. 7 by 9. You can put opposite side. So tan theta is equal to 9 by 7 and sin theta is equal to 9 divided by root 130. Cos theta root 7 by 130. That we know, right? Sin theta, if you want sin theta. So the take, right, this 9 divided by root 9 square plus a 7 square. Similarly, cos theta is equal to 7 by under root the similar values. Oh, good. Now we have cos theta and sin theta. Can we use reuse this equation 1? Yes, of course we can use. So u square sin 2 theta is equal to 180 sin 2 theta is equal to 2 sin theta cos theta. We have value of sin theta cos theta. U square 2 sin theta cos theta. Put this value here. Oh, now solve this big equation and you have u is equal to 13.6 meter per second. Remember that you don't have calculator during examination, so you have to be habited to solve this kind of thick examples. But see, mainly in JEE NEET, you don't have this kind of big uh, calculations. You have very small calculations, and mostly you have answers in terms of root or something like that. So bigger calculation is majorly not required for JEE NEET examination. We have one more example. A particle is projected over a triangle. Wow. So there is a one triangle is given. There is a one triangle which is solid one. Let us assume the triangle building shape is given. So object is projected from this point over the triangular. So one of the end of horizontal base and grazing the vertex. So this is vertex falls on the other end. So it starts with this. It just touch this vertex and it falls on the opposite side. Wow. If A and B, the base angle and Q, let us assume just theta, angle of the projection. Theta is the angle of projection. See, A, or you can say alpha and beta. It is alpha and beta are the angle for the triangle. Alpha and beta are angle for the triangle, and theta is the projection angle. So this is theta is the projection angle. We need to prove tan theta is equal to tan alpha plus tan beta. See, this may be given as option number A, option number B, option number C, option number D in the examination. That's possible. So here tan alpha plus beta, can we write this triangle here? This is our triangle. This is alpha. So can I write tan alpha is equal to nearer side? Tan alpha is equal to not nearer side. It is a perpendicular side. So y by x. So tan alpha and another triangle it is here. Let's change the color. we have another triangle, and that angle is beta. Can we have tan beta? Yes, this is y and this is given r minus x. So we can take y divided by r minus x. Similar here, see tan alpha plus tan beta. Here it is y by x, and here it is y by r minus x. Then what next? See tan alpha plus beta, we can just rewrite this. We can put here y multiplied by r minus x minus rx. Can we have y r minus x y minus plus x y divided by something x divided by r minus x. So here it is to be cancelled and it become y r x divided by r minus x. So we got some relation for this side, tan alpha and tan beta, and is equal to tan theta. We have very clear equation. We have big equation. Tan theta is equal to x. Y is equal to x tan theta minus. Oh, big equation. Also, we have this equation. Y is equal to x tan theta 1 minus x by r. So tan theta we can take one side. Tan theta is equal to y by x. If I take this r minus, so this equation become like that. R minus x divided by r. It goes on opposite side, so it becomes r by r minus x, so equal to y by r. If you just compare these two, 1 and 2, can we say both are equal? Yes, of course, both are equal. Therefore, tan theta is equal to tan alpha plus tan beta. It is proved. Example number 15 is here. A body is projected with a velocity u at an angle theta. So first, state initial and final velocities in the form of vector. We can represent in the form of vector also. Second is find velocity, vector and direction of motion after a given time. Third is find coordinates of a particle after a given time t. Fourth, velocity and direction of motion at a given height. See all the possible questions we will be taking, right? So you will not be having any surprise in the examination. Be ready for all the options. So first, see when we talk about initial velocity, so u is initial velocity which is given at theta. So we know that there are two components, one is ux and another is uy. Ux is equal to u, nearer angle is cos, so cos theta, and uy is equal to u sin theta. That we know very well. So if you wanted to represent this in the vector form, here we just need to have the direction. This direction, it shows I shows x direction and j shows y direction. So we can put here like initially u bar is equal to u cos theta I, u sin theta j. So this is vector form. This is vector form. Now, so we got initial form of vector. Now we are talking about final form of vector. See, final form of vector. So initially, when the body moves in the horizontal direction, so ux it is not having any acceleration. So ux is constant. It is not changing. It is having constant velocity. So at a time of initial or final position, if we have here the final position, so ux remain ux. So ux, you can set ux is equal to u sin theta, or you can write is equal to v sin theta. U is initial velocity, v is final velocity. But when we talk about this y component, so initially see object it is having in this direction ux and the vertical uy, and y component decreases with time, and ultimately here uy becomes 0, uy becomes 0, and then uy become negative. Here ux and uy become negative, uy become negative, increases, and here the final component is like that, u y. It is negative. It become negative. So therefore, uy, it is again, if it is minus, but it is sine theta, but it is minus v sine theta, and therefore v is equal to final component v vector is equal to v cos theta I minus, it become minus, it become negative v sine theta. See, in this case we are assuming that there is no loss of energy, or simply we are neglecting air resistance. Therefore u is equal to v at initial and final position. At initial and final position, this is true, and therefore u is equal to v for this case. So this is example number 1, it is done. Then find the velocity vector and direction of a motion after a given time. Maybe after a given time, maybe assume, let's assume after given time t. At here, at here, at here, we need to identify its velocity vector. So we have equation in terms of Vx. So we have equation V is equal to U plus AT. We have equation is equal to U plus AT. So we have horizontal component. For the horizontal component, see, this gives Ux, this gives Ux, and here there is no acceleration. So acceleration is equal to 0. Acceleration is equal to 0, right? So U is not changing at all. If you wanted to have our values at particular point, say for example here, so I can take U, or simply I can take V after some time. So V is equal to U, V is equal to Ux, Ux in the horizontal direction, Ux plus AT. But acceleration is 0 for horizontal component x. If I take x, acceleration is equal to 0. That means Vx is equal to Ux after some time. So it is not changing, it is not changing. But if I take this in terms of y, vertical component, if we take vertical component, so uv, you can take uy plus a become minus g, a become minus g. So that is the difference. You can see here. So vx is equal to u cos theta. We know that ux is equal to u cos theta. Vy is equal to u sin theta minus gt, because vertical component reduces. Vertical component, its effect reduces over time. At here top position, it becomes 0 and further increases in the negative direction. So now we have this is I component, this becomes j component, let's have I plus j. V bar is equal to u cos theta I plus u sin theta minus gt. So that becomes vector. That is a vector. So we got velocity vector, and we need direction. Now we need direction. So theta is equal to vertical distance divided by horizontal distance, or vertical velocity divided by horizontal distance, horizontal velocity. So tan theta is equal to Vy, vertical movement. This is vertical divided by horizontal. See, angle changes. See, here you have to consider. See, this is maximum theta. Then angle of movement is changing. Angle of this projection changing. If you take here, it becomes 0. It becomes 0. Here again further changes. Further changes. So angle keeps on changing. Angle keeps on changing. We need angle at particular time. So you can take this distances, or you can take velocity at this position u v x, here vy. So vy by vx, it gives us its angle. So tan theta is equal to vy by vx is equal to u sin theta. Put this just here and divided by u cos theta. So second one is done. Third, find coordinate of a particle after given time. Now we need a coordinate. See, the previous one, it was for velocity. Now we need a coordinates here. We need a coordinates. What is x position and what is y position, that we are looking for. So for the coordinates, we have equation s is equal to ut plus 1 half at square. If we need to have x direction, x ux. Time is similar for both. See, in the x direction acceleration, there is no acceleration component. So sx, that become x, is equal to ux become u cos theta multiplied by t. So here you can see sx is equal to ut cos theta. But what about if it is y? So it become y, uy, and ay. So sy, that become y, uy become u sin theta t. Here minus 1 of gt square, because acceleration is negative for the body which is freely moving. So we can see here this become syut sin theta minus 1 of gt square. Now what next? Vector, we got the vector s bar is equal to ut cos theta I plus this is put here to the j form, and if you want its solution, so you can take mode s is equal to root first component x square plus sy square. You can derive this equation from that. And the fourth one, velocity and direction motion at a height, at a particular height. If you want it to have height, so we have equation v square minus u square is equal to 2as. See, all the possibilities we have to go with all the possibilities, and we have to be ready with all the possibilities. So here become vx ux is equal to 2as. What is acceleration along x direction? X direction acceleration is equal to 0. So become vx square is equal to ux square. Similar action, vx is equal to ux, v is equal to u cos theta. So we have here. And what about vertical? So we can change here y. See what is given here: velocity and direction of the motion at a given height, at a given height. So vy square. We can put vy square equation vy square, then minus uy square. We have equation for uy square also. So vy square minus uy is equal to u sin theta square is equal to minus 2gh, because acceleration become minus g, right? S become vertical height, so you can take h over y, and ultimately you just put here all the values here. Vx is equal to vx square plus vy, and put the values and you find your answer. So velocity in the relation with height, you will, by resolving this, you will get u square minus 2gh. Show me the process in the comment box. Please comment. And angle, we know that y divided by vx tan theta, the similar equation will be there. If you wanted to have angle theta, so always we know that ABC tan theta is equal to BC divided by AC. You do this, it is applicable to all. So we have question from NEET 2013. What is asked? The velocity of a projectile at the initial point A. So say for example, initial point A is given here, and A is 2i plus 3j. A is given 2i plus 3j. Its final velocity, or its velocity in meter per second at final point B, so B point is here, is asked NEET 2013. And see here, answers are given like that. A is equal to 2i plus 3j. So A is given minus 2j minus 3j. B is given minus 2j plus 3j. C is given minus plus 2j minus 3j. See here, let's have this is I component, that means x component minus 2i, and the y component, that means minus 3j. Is it minus? No, it is plus 3j plus 2i. See, we know that during this entire movement, during this entire motion, x component always remain positive and it always remain 2. So if you go here, it is 2. If you have anywhere, It is always 2. So plus 2, the first component should be plus 2. It is not changing. X directional component is not changing. So answer number A is having minus 2. So this answer is not possible. B is also having minus 2. It is not possible. Right. So C and D, there are two options are there. Only two options are there. So when the initial velocity is equal to ux is equal to u cos theta, uy sin theta, that we know, this is very well known fact. So vector form you can write u cos theta I plus v sin theta c, and then see, maybe object may be starting from this position and is having vector, what it is having vector 2j plus 3i. So see, 2j is not changing. Say for example, if it is here, 2j is not changing, but it become minus 3j here on the opposite side. But 3 component, when it goes in the upside, 3 component, it decreases to 0. So it here it become 2j minus 3, not 3, here it should be 0j. When it go in opposite direction, so this become minus 1j minus 2j, and therefore, see, you cannot have A is 2i plus 3j multiple times. At point A and at point B, this both values should be different. You cannot equal values, therefore D is wrong. Only possible is C. Only possible is C. So we know that maybe downward motion it is showing that final velocity, and therefore projectile motion only velocity y component changes, where x component is remain constant. Therefore option number C should be the correct answer. See, this much explanation is not required. You can directly solve by yourself. We have example number 17. A body is projected with a velocity 20 meter per second in a direction making an angle 60 degrees. So u is given 20 meter per second, theta is given 60 degree with the horizontal. Calculate position after 0.5 second. T is equal to T1 is equal to 0.5 second, and velocity also you need to find out velocity. Wow, it is very simple question. How can you ask this simple questions? U is 30 meter per second, theta is 60 meter per second. So we have the big S x. We have Sx is equal to u t cos theta, Sy is equal to u t sin theta minus 1 of gt square. So you can put x is equal to 20 multiplied by 0.5 cos theta. You can find, see, position. For the position, we know that S is equal to ut plus 1 half at square. I have to repeat this all every time. You don't remember this. So if I just wanted to have as x means position in the x direction. So x direction acceleration is 0. There is no acceleration. So as x is equal to uxt. And what is ux? What is ux? Ux is equal to u cos theta. So is equal to u cos theta t is equal to ut cos theta. Then the similar case is here. Ux means as x is equal to ut cos theta. Put the values here, you will have ux. And for the y component, Sy means vertical distance. Wow. Ay is equal to minus g. Uy is equal to u sin theta, because theta is not nearer angle. So put here Sy, that means y. Sy, that means y is equal to u sin theta t minus 1 of gt square. So similar it is mentioned here. Put the values here and you will have solutions for that. As x means along the x direction, This is x direction movement and this is y. So x and y. Sx is equal to 5 meter. Ultimately, you can say x is equal to 5 meter and y is equal to 7.4 meter. After how many second? After 5 second, and then next is you can write s is equal to 5i plus 7.5 j in the terms of vector. Also, you can mention if you wanted to have a theta, then we can get it right. Then we need a velocity. We need a velocity equation. V is equal to u plus at. For the x, you can write vx, ux. X direction is not having any acceleration. Therefore, Vx is equal to Ux is equal to U cos theta. Wow. And for Vy is equal to Uy minus Gt. Put this value here. So put the value here after 0.5 second, not 55 second, like 0.5 second. Vx is equal to 20 cos 60, Vy is equal to 20 sin 60. Put the values here and you will have Vx is equal to 10, Vy is equal to 12.3. You can put this in terms of vector also if it is asked. So we need velocity. So we need to have velocity in terms of mode. V under root 2 400 square plus 250 square is equal to 472 meter per second. Wow. Simply it is wow. Wow. We have one more example. Example number 18. A body is projected with a velocity 5 meter per second. So u is given 5 meter per second at an angle of theta is 37 is you. See, whenever there is a 37 angle, you remember 3, 4, 5. Opposite to the 3, the number is 3, near it is 4, and the remaining bigger one is 5, but hypotenuse. First, a state initial and final velocities in vector form. Again, we have similar kind of questions. We have a similar kind of question. So we have here in this direction ux is equal to u cos theta, and here uy is equal to u sin theta. Theta is equal to 37 is given. Second is find the velocity vector speed and its angle with hp after 5 seconds. Find the displacement and vector displacement after 5 seconds. So we need magnitude and displacement vector both. So u is equal to 5 meter per second, theta is 37 is given. Initial vector ux is equal to u cos theta, uy is equal to u sin theta. That we know it very well. So vector form is given. But what about final velocity vector? What about final velocity vector? See, body is starting from here and it goes on the opposite side. So horizontal vector, it is remain same throughout the journey, but the vertical vector become negative. So what you put? You put the values here. V 500 cos theta is 37. So cos 37 is equal to nearer side 4 by hypotenuse, and the sine 37 is equal to opposite side divided by hypotenuse. That we know it. We can put the values here. The answer V is equal to vector is available. So U is equal to 400 I plus 3j initial vector. Final vector Vx is equal to V cos theta, and we know that this become negative. This become vertical component become negative, so become minus U sin theta, and the horizontal component remain constant. It is U cos theta. There is no change in horizontal component. So put the values here, all the values here, 400 I minus 300 J. Only this is the change. Only this is the change. No further calculation is required. You can do it. Then second, find the velocity vector. Oh, velocity vector. So we know that V is equal to U, V is equal to U plus AT. For horizontal, A is equal to 0, AX is equal to 0, Ay is equal to minus g. Put this value here and you find this. After 5 seconds, suppose t is equal to 5 seconds. So put all the values here. You can have Vx is equal to 400, Vi is equal to 250. So we got displacement vector. No, we got velocity vector. We need speed. That means what? Magnitude. Oh, magnitude. V bar is equal to 400 square plus 250 square is equal to 472 meter per second. And the angle. So we know that tan theta is equal to Vy by Vx. 250 by 400. So theta is equal to 32. Theta is equal to 32. Wow. Then we need find the displacement. So we have equation for displacement. S is equal to ut plus 1 half at square. For horizontal ax is equal to 0. Ay is equal to minus g. So put this value here and we have the above equation. We have above equation. Sx is equal to 500. 5 cos 37. So cos 37 is equal to 4 by 5. And sin 37 is equal to 3 by 5. Put these values here. Sx and s is equal to 200i plus 1375j. And also we need displacement. That means magnitude of mode s is required. Under root. Put this s is equal to root under root s x square plus s y square. Why don't you put your answer in the comment section? I will waiting for your answer. Put your answer in the comment section. I need it. One more question we have here. Example number 19. The trajectory of a projectile. So projectile is given y is equal to x minus px square, where a, b are constant and x and y are respectively the horizontal and vertical distances of the projectile from the point of the projection that we know as story. Thus, we need this example y is equal to ax minus bx square. The maximum height. Oh, we need maximum height and the angle of projection from the horizontal. So, object is thrown like that. We need to have theta and we need maximum height. Oh, so equation is given. See, whenever we need some kind of maximum or minimum component. So if we do differentiation, say for example, this is my object, and if we do differentiation dx or dy by dx, simply dy by dx, and this giving x versus y, right? If I do dy by dx, so when this difference is zero, dy by dx shows difference. So it is possible at maximum point. Or maybe it is also possible if I draw this, expand this, so it is minimum. See, in the projectile, only one possibility, it is maximum. So if you take differentiation dy by dx, if you take this is equal to 0, dy by dx is equal to 0, slope is 0, you will get maximum value. You will get maximum value of y, distance. We will also study this in detail, right? But you just remember as of now what we are talking about. So differentiation, we have a differentiation. So y is equal to ax, differentiation of become a minus x square become 2, so 2b. A is equal to minus 2b, x is equal to 0. We can have x is equal to a by b. So x is a by b, x is a by b. At x is equal to a divided by y should be maximum. At x is equal to a by b, y should be maximum. Why don't we put this value in the x? So y is equal to ax minus bx square. Put this value here. A become ax a square divided by 2b minus here 1b can be cancelled out, a square divided by 4b, so is equal to a square divided by 4b. The maximum height is equal to a square by 4b. Oh, ho, ho. Then we need angle of horizontal. Ultimately, see dy by dx. We know that. We know that slope is equal to dy by dx is equal to tan theta. at x is equal to 0, at x is equal to 0, at x is equal to 0. See, position is like that. Why x is equal to 0? This is whole equation of this entire motion is given, and here x is equal to 0. Here x is maximum, and slope of this component is tan theta. Tangent, we know that tangent is a tan theta. So tan theta is equal to dy by dx. At x is equal to 0, we need tan theta at x is equal to 0. So put x is equal to 0 in this equation. So it is equal to a. So at beginning x is equal to 0. Slope is a. A. So tan theta is equal to tan inverse a. Theta is equal to tan inverse a. Wow. Oh, JEE 2019 mains exam question. We have example number 22 guns. So firing. Shum, shum. Two guns A and B can fire bullets at speed UA 1 kilometer per second and UB 2 kilometer per second, respectively, from the point on a horizontal ground. They are fired in all possible directions. So it is something like that. Here it was fired. Say for example, UA it is fired. Right. Let's see, this is top view. So it may fired in all the possible direction. The ratio of maximum areas covered. See, this is area. That means fired in all the direction, fired in the direction, fired in the direction, fired in the opposite direction. Wow. And this is another, it is having similar. So, yeah, the ratio of maximum areas covered by the bullet on the ground fired by the two guns is 1 by 4, 1 by 16, 1 by 8, 1 by 2. JEE 2019 mains exam. Wow, must. Wow, excellent question. So bullets are fired. See, when we fired a bullet, or you can say object is having a projectile movement, and to achieve a maximum range, it should be fired at 45 degree. It should be fired at 45 degree. That firing should happen at 45 degree. We know that if a cricketer wants to have a maximum range, means maximum displacement, theta should be 45 degree. Wow. So we know the R maximum is equal to U square by G. So first gun, it is in the one direction. It is can have R max. If you shoot at 45 degrees, so bullet travels maximum. R maximum is equal to U square. The sine 45 multiplied by 2, 90. So it becomes 1. So it is not required. R maximum, we already proved this equation. R maximum is equal to U square by G. Put the values here. And similar here for the RB also 45 degree. So RA maximum is equal to 1 square by 10, RB maximum is equal to 2 square by 10. Let's divide this a ratio RA by RB. So see, here it is asked that it is not direct ratio, it is not RA by RB, but see here we have to remember the ratio of maximum area. So bullet is fired in the all the direction, in this direction, in this direction, the opposite direction. So this is circle, the top view, top view. So it takes all of this region, and we know that it become pi r square. Area of this circle become pi r square. So this is pi r a square divided by pi r b square. Pi cancel. Let's put the values here. 4. So it become 1 1 by 4 square. So become 1 by 16. 1 by 16. Yes, we have answer. See here, this kind of questions you have lot of chances to have a mistake. First mistake may occur where you don't take range as a maximum, right? And you just take theta as you just wanted to have theta. What should be the theta, right? So first mistake is there. If you take any angle of theta, in this case also answer will be same. If you take sine 30, because we are taking ratio, so 30 will be cancelled out. So it want nothing to worry about that one. Second point is that, see, students want take here area. You just divide R A divided by R B like that, and it won't work. So it become 1 by 4, but it is not r square by r area. So there are chances where you get mistake. So you have to avoid these chances to have mistakes. So B is 1 by 16 is correct answer. We have example number 21. For angles of projection of projectile at an angle 45 minus, this is assume that this is theta, and 45 plus theta. See, we have that whenever there is a 45 minus theta plus 45 minus theta plus theta, so is equal to 90 degree. What is on the horizontal ranges described by the projection are in the ratio of, this is all India pre-medical test 2016 it was asked. See it like that, body starts from this position, angle is 45 minus theta, another body travels with this position 45 minus theta. If this angle is total is 90, so it always range is equal, and one is correct answer. So horizontal ranges of complementary angles means 90 plus theta becomes 0. That means addition of two angles gives 90 degree, hence horizontal range is equal. Horizontal range is equal for this. Thus required ratio is 1:1. So thank you very much for watching Physics Doctor. My name is Dr. Gansham Tejani. You please subscribe my channel. We will complete the whole syllabus of physics, and we will be taking all the examples from easy to medium to difficult, as well as we will be covering all the NEET examples as well as JEE examples. Thank you once again.